So now that I've given an overview of the MathServices app case study, let's focus in on one of its microservices. This is the Primality microservice. And we're going to talk about the structure and functionality of the Primality Controller and the Primality Service that are used to implement this microservice and how this particular approach applies Java structured concurrency. And in fact, we're going to use the Executors VirtualThreadPerTaskExecutor model. So this is what the controller looks like. Not a lot of surprises here. Quite frankly, you've seen this kind of stuff before. We've got a controller that we designate through annotations to be a REST controller, which means that we can automatically do the mapping. The Spring will do the mapping of the incoming HTTP requests to the various methods that are defined here, and we can get back the objects that are serialized properly and so on and so forth. We're going to auto-wire our field that accesses the service. Again, no real surprise there. We've seen this over and over again. We're going to have a method called check primalities, and this is going to take a list of integers, which are the prime candidates, and it's going to forward it down to the prime service method with the same name to do the dirty work. And we use the get mapping to instruct Spring that this is where you're going to be routing incoming URLs that have the check primality list path as their routing name. And so we have to put that in there, of course. And then we also have to indicate that the prime candidates parameter is indeed able to handle a list of something. So we put the request param annotation there. Nothing surprising at this point at all. Let's take a look at the implementation of the Primality service itself. This, of course, is what defines the method or methods that do the work. And you can see here that we define this as a service so that we can have Spring do auto detection and wiring of various parts using dependency injection, using so-called class path scanning. And here we have the check primalities method, which that you see at this point no longer has any annotations in it. It's just good old Java code. And that concurrently will compute the primality of the prime candidate parameter and return a list of prime result objects that indicate what the mapping, what the result was of each prime candidate to whether it's prime or not. It's implemented internally using Java structured concurrency via the VirtualThreadPerTaskExecutor model. We'll take a closer look at this in just a bit. But one of the things I want you to notice here is by using this approach, we separate out the method that goes ahead and submits the requests to go and check for primality. We separate that from what we do when we get the results back, which of course will come back as a list of futures to prime results. And so we have to do a little conversion in order to make the change from a list of futures to prime results to a list of prime results. So that's always the thing to keep in mind when you use any of the Java structured concurrency models. You have to do some conversion to get back in the format that the client expects the results to come back as. So that's the end of the overview of this particular approach. Keep in mind things like this, because when we talk about the alternative approach using Java parallel streams, I think it's very instructive to compare and contrast the amount of ceremony you have to do with one approach versus the amount of ceremony you have to do with the other approach. But we'll talk about that in just a moment.